Hello everyone and happy Friday. Hopefully you are ready for a weekend. But today we are going to discuss a very important topic that play a very critical role in building our professional skills. So far we have seen we were working with the single table queries where we are just selecting or extracting data from one table. Now we are going to actually take the next step, and we're gonna add more table, and we're gonna see how we can join multiple tables together to generate the outcome that normally used by the business or any other system which are expecting information from our system or the databases. Joining is one of the most important thing because that will help you to form the final outcome, and it works on all stages of the data life cycle. You use them into building a query where you are not actually reading the full plain table, where you need to massage the information together and then load it, where you first transform and then extract, transform and load, normally a common scenario. You also use them when you want to load the data in from one stage to another stage during your data life cycle. So for example, if you are getting the data and you want to have multiple system, and then you have a target table where you want to load the data so it can be used for the reporting. So that's where you use the joins as well, so you can actually connect the dots or connect these table to generate the right outcome, and that it can go and it can be used behind it can be used within that table, or that table can be used by the report or the dashboard. And obviously we can use the views as well with a similar way like we are using our script. And I'm not actually going towards view intentionally, because as soon as we are good with the selection queries, then these additional things, they are a bit, I would say, simpler to understand. The most complicated is to build the queries that can extract the information from all these sort of data sources which are now around us, and present it to the business. Now, the next thing, which obviously in the same pattern, is whenever we want to show the information to the user or to the business, we need to get information from multiple table. So now I have seen that, especially with the Power BI interfaces or the Power BI internal data modeling, we have a different query model which we can use to merge these table together. But it's a debatable topic where you want to keep your logic. Theoretically, we keep all the logic on the databases because these databases under the control of data governance, and because these data assets are maintained by data governance and they're making sure all the policies have been applied. If you take out the business logic out of it, that's not going to actually help it on the longer term. Then by that action, we start creating the data silos within our organization, and at some stage these silos and the logic it has produced, it has multiple versions that has been used by the business, and then it starts creating confusion between the department, that nobody knows who has the right information and nobody knows who has the right business logic, right? Because business logic is not a stationary thing. Remember, it's going to evolve over time and time, right? So that's why we prefer to keep the business logic and keep all the joining in and the script on the database level. So whoever design it, the data governance, or the stakeholders are aware of the development of the logic, and they can take the ownership of that logic because it's going to be centralized into our data platform. But anyway, like I mentioned, it's a debatable topic in the industry. We have seen that there are arguments on the other side as well, because obviously if we don't have the enterprise solution implemented in our organization, then most organization would like to to have information quickly available, instead of focusing of putting everything on its place in a proper fashion. These are the argument on both sides. But anyway, what we're gonna do today, we're gonna learn the joins, how we can use join, how you can generate some professional outputs by using your SQL skills, and then we'll see how we can do the similar thing on the big data stack as well. So by saying it, let's jump into the picture, and then we'll go into the demo environment. All right. So I think a picture is worth of 1,000 words. So that's why I think that's the very simple way to explain how the joins work, and how you can always remember whenever you have a requirement. These requirement tells you what kind of join you are going to use it, right? Because they normally, once business send you the report requirement or any data extraction requirement, or even you are building the full solution, each step of the solution that's going to actually describe you what kind of join you need, right? So we'll go through the joins first, and then we'll see them in action, and then you're gonna see how they differ to each other. So we have categorized into two joins. One is the inner join, and the second one is the outer join. Obviously, inner join, I have divided it into two types, and I'm going to explain why I put it into the two types. By the way, the second type we are going to implement today by ourselves, because that is not available normally into the database software or the SQL language. But we are developer, we can do it, right? So no problem on that. Let me first explain. So imagine you have one table called A, and then you have another table called B. So everything which is common between table A and B, and obviously once we say it's common, we need to find out what attributes we are going to use to define the commonalities, because maybe this A table, it has 10 attributes, this B table, it has 15 attributes. So which attribute is going to generate the criteria of matching the records from table A to records from table B, right? So we need some sort of column that can actually define that matching pattern, and that will actually compare the rows between both table, and only get the part where both table has the common values of that column on both sides. So you can see where we have the attribute, first common attribute between both table, and then it's only going to extract those records where the values of each sides of that particular attribute are matching together. So for example, if we have, for example, user ID, which is a unique value of the user table, and on the other side we have, for example, the user is rating a book or or a product. So we have the user rating table, and in that table we have the user ID as well. So once we compare, or once we find the inner join, or once we link these two table in the inner join fashion, then the SQL will return only those records where user ID of table A is going to match the user ID of table B. So that's going to show us that overlap area between these two tables, which mention that the column values of both tables are similar, right? So that's what we call inner join. Obviously, the outer join, anti-inner join is complete the opposite. Like it's going to return me all those user ID which exist in table A, or for example from table user, but they are not providing rating. And it's going to give me all the rating which are not have the user ID which is sitting in the table A. So for example, we have some blank record, or we have some garbage value or which is coming in here which is not sitting in table A. So those records we can, if we want to extract on both sides, those where there are no match between these two tables, we can extract through anti-inner join. Now, the second type for us is the outer join, which is obviously is different. So, for example, you need the information where both tables we are joining, have the similar user info, user key or user ID, but also we want to see what else has been available in the user table, which is not present in the book rating or product rating or even rating table, right? So in order to do it, so that means why we called it outer join, because it takes whatever coming as part of the inner, plus it takes some outer values as well. Now, what outer values? Because we have now two dimensions. We have the left side and we have the right side. So in the left outer join, so that's why we have the left and right. So in the left outer join, it takes whatever coming out from the inner join where both sides are matching, plus it is taking the left side completely. So whatever is gonna remain on left side is gonna add that as well in the output. And obviously the corresponding side of the right side for those value which are coming extra from left side, those values are going to be empty or null. Same concept apply on the right outer join. Right outer join take out the outcome where the values on both sides are matching to each other based on the key value, as well as whatever left on the right hand side. And obviously, if there is no matching on the right side, on the left side in the right outer join, we're gonna have all the null values sitting into those columns which we are reading from left side. So pretty simple, right? Because the diagrams are clearly explaining the concept. Now, last but not the least is full outer join. So for example, if we want to bring the output where we need to see, okay, what we have available on the overlapping area, or what we have available as common between those tables, as well as what is available on the left hand side and what is available on the right hand side. So we need those, right? So that's going to actually provide you the full outer join. So that will actually bring both tables, but in a fashion where we have the common values based on the common value criteria, for example, user ID, and then we have whatever left which is not matching on the other side from user table or table A, or also table B. So that's what we call full outer join. Each join has its own use cases, and they help us to build our scripts. Just take the concept and understand the functionality by looking at the demo. Once you start collecting these things together, trust me, you're gonna start, building the solution that is part of, your data management, and I would say data preparation skill, which is the core part of data engineering. So by saying it, to see it practically in action, let's jump into our demo video, demo environment. So if I come in here and let me share my screen. All right, so you can see I've already prepared today we have new table. So far we have actually used person table. Now we're gonna move towards next step. We are using some professional data. I would say because later on just get you excited. We're gonna use it for the machine learning. Once we're gonna build the recommendation system using the machine learning technique. You're gonna see how you actually prepare the feature set for your machine learning work, and you can literally apply machine learning techniques within the SQL environment without any exception. But we are not going to stick only to SQL. We're going to look into Spark as well, and obviously from Python as well, because these are the two major players at the moment. SQL we are using for our own learning perspective, but I would say the Spark and Python are the two major key players in the industry for machine learning or artificial intelligence work. But remember, the journey starts from the data. So let's come back towards the data. Let me first explain the table. So we have three tables. One table is containing user data. The other table is containing the book information. So, for example, we are running a publication portal where we are publishing books which are authored by some really great authors of today and in the past time. And now we are collecting the information. Okay, what users we are getting, where the location of these users are, what is the age, and what rating they are doing, because obviously in order to improve our business we need to see, sometimes it's not possible for all the users to see the full book catalog, right? Nobody has a time. Normally they once they come into the website, they have a bookshelf in front of them, they pick it up, and then they go back and they either purchase it or lease it, and they come after some time, and now you have the opportunity to recommend. Remember this, now you have opportunity to recommend another book which is similar the one which is previously taken by this user. So that's where the whole machine learning starts shining, because this will actually help user to engage with your business, engage with your website, and then based on the recommendation, sometimes they picked it up, sometimes they ignore it, and then they pick another one. But that doesn't mean that your machine learning algorithm has been failed. No, because this is a user behavior. Once you pick another one, you're going to actually take out to read that action, and next time you're going to refine your recommendation, right? Why I'm explaining side by side? Because everything, imagine whatever we are doing in the machine learning, it is all based on how nicely we structure the data, right? So coming back to data, because we need to explain it, let me first run the first table structure in front of you. Imagine we only have these three tables. We have the user ID, which is uniquely identifying the user key. We have the location, and we have the age. Obviously, we are not keeping the first name and last name and additional attributes. You can do it if you have that information, if you want to paste it. And by the way, why I'm not doing it, I'm going to actually explain once we come towards the machine learning side. Then we have the book table. Book table is containing all the book information, the attributes which are there. So for example, you can see we have the book title, we have the book author, year of publication, publisher, and then we have some additional attributes like image, URL, blah, blah, blah. So you can see we have a proper book information, or like I mentioned before, we can extend it if we want to, but I think at this stage that's going to be enough for me. Last but not the least, we have a table which is containing the book rating. So once user read our book, what rating this guy is giving to us, right? So that's a very important thing, right? That will help us to understand that okay, whether our user is liking our bookshelf or not, because that will keep your business running, right? There's no point for us to keep running our book website or publication website, and where people are not even bothering to come and buy or lease the books, right? So we need to make sure, we need to keep looking at the rating, and we need to make sure we can improve these ratings. So that's why we have the third table, where you can see we have user information with the ISBN. And by the way, ISBN is the unique identifier for any book, and you can find it on each book. Whenever the book has been published, it actually got the ISBN number, and that will uniquely identify this book throughout its life, because that number cannot be assigned to any other publication, right? This is more like the standard, and I would say the stamp that can only stamp on that object, that never been used for any other purposes, right? So that's what ISBN number. And last but not the least, you can see we have the book rating. So let's start our first exercise. What are we are going to do? So these three queries are showing us the full table information, or our schema information. We are going to write the information. So for example, and I'm going to use a couple of shortcuts. I'm going to do a lot of copy paste because I don't want to type. So we have inner join command in our SQL server available that will actually join us two objects or two table based on some condition. And like I mentioned in the diagram, once we connect these two objects, we need to provide some common criteria, and it can be one attribute, or it can be multiple attributes. So let me use it. Let me use one table, obviously. Sorry. Let me use one attribute on each side, because that will be simplified. And in this scenario, we only have one attribute. So we are going to use user ID. And by the way, whenever you see there's a pink color, and that means that's the reserved word as well. And just to actually show it to you, and I'm going to show you how you can use these. Right, so you can see we have the user ID as a function available within the SQL environment, but you can still use it. Just put them in the square brackets, right? Now, what I'm going to do, so I'm keeping my user on the left side, because that's obviously going to be my main user table, and that's how you define from parent to child. So in parent, always the parent table, and parent, how we identify the parent, where the instance is going to be unique of that particular object. So because I'm looking at the relationship between user and a book rating, so I'm going to see where and I'm going to join it based on the user ID. So I need to look at where my user is defined uniquely. So I can clearly see that's the table which is uniquely defined my user, because it might be possible in the book rating, user is giving rating for more than one book. So that means user ID is going to be duplicated on the right hand side. So that's why we are not keeping it on the left side. And then obviously I need to put that in here. All right. So again, the color has been changed. Let me turn into right color. So we are good, right? So we can see we have joined two tables. And let me run it. It's going to take a while because we have big data set, because remember, we're going to use it for some of the machine learning exercises. You can see, I think we have almost 1.1 million records sitting in the rating table, right? Just to clarify that, let me quickly show you the count of the table. So you have, so you can see we have a 1.149 million record in our book rating table, right? Let me also show you a similar way. For our user table. So we have 276,000 user records available. So now it's a very handsome data set which we can use. And normally, tell you the truth, for machine learning models, we have very large data sets, and you can see that's where the whole processing and efficiency come into the place, because we need to build a model that can digest these data sets. Okay, so I think we are pretty good in terms of our joining. Let me just mention in a demo, we have joined these two tables, and you can see these two tables we are joining on the user key. Let's run it. And you can see we have all the user information as well as the rating information coming from both sides. But now there is a problem in inner join. Is awesome, like I can see 1138481 record, but I'm not sure whether I have any user who hasn't provided even a single rating. I'm gonna see it, so that's where we are moving away from inner join, because even inner join is beautiful in terms of connecting the tables to produce the combined outputs based on a common criteria, but sometimes the requirement is not like up to the commonality. We need to investigate, if do we have any user who hasn't actually read any book, so we can find out what's going on with these users, whether they are liking, or what's why they are not why they are not giving score or rating to the book which they are reading. Because sometimes, I tell you, sometimes it creates a great pitch for sales department, tell you the truth, because these are the areas where the analytics really shine. It helps the business to explore those areas which are hidden somewhere, and these trends identify this pattern and push people to follow and increase the business. So what we can do, I'm just going to do a couple of changes before we move on. I'm going to show you a trick. If you press Shift Control Q, you're going to see a query designer, and you can see exactly the inner join in action by in a graphical manner. So that's diamond sign that will show the inner join, and even if you hover over it, it's going to actually show you that the join that has been made between these two is the inner join. And you can see we are getting information on both sides. I'm just going to take out this user ID from here because that is repeating. I already have the user ID coming from my user table. And then the rest of the information looks good. So I'm going to keep it as it is. And if I click OK, you see it's going to format it by itself. But I can adjust it, which is good. Like you can see now we have, so what I can do, let me just do this way, so that will be much easier. I want to keep the condition in the next one. And one thing I'm going to do, I'm just going to put the square brackets so you guys can see there's no confusion. By the way, you can see location is also the reserved word or the word that has been used by the SQL. That's why it's coming under the different color. So like I mentioned, we can change it. And that's our nice, beautiful inner join. Right? We have that information, which is good, and both sides have been matched. Now, what we are going to do as a next step, we are going to find out, is there any user which is sitting on the user side who hasn't actually read any book, right? So in order to do it, you can imagine we first need to implement the left outer join, right? Because inner join is not going to help us. So I've just copied it and left. Once you understand one join, the other joins are going to be very easy to implement, because all you need to, just replace the keyword outer join. So you can see I just, instead of using inner join, I'm using the left outer join. And now in the left outer join, let me just show it to you. The icon has been changed, and you can see, like on your screen, it is going to get all the information. So you can see the diamond is still there, but there's an extra object on top of it, which is showing that it will get the information. And you can see that particular icon, additional icon, on the side it is referring, it is going to get the information from that side. So that means if it is on the left side of the diamond, that means we're going to get all the records from the left side, which are addition to the common records. So let's run it. And previously, don't forget that we have a count. So let me just write the count in here. Sorry. Records return 1138.1. Right now, let me run this query. And like I mentioned, I'm a bit, lazy in typing. So I'm just going to type, and I'm going to change the number 1310457. Right? So you can see we have some, that means we have some user or some customer in our bookshop who are not providing rating to the books, right? So we need to find out. First, we're gonna see how many these users are. What's the count? So let me quickly do the calculator. You can see. So 1310457, and we are subtracting it from 1138481, right? 481. We have 171,000 users who are not providing the rating to the books now. That is pretty alarming to our business, because who knows what these people are thinking. They are not liking our business, and they might have some problem. They are not liking the website. There must be something that our marketing and sales teams need to find out, right? So now you can see that's what the analytics is. It's not like, imagine we are now moving towards the real stuff, right? As soon as we jump into the joins and the upcoming topic, they're going to drag you more and more towards the professional side, right? So what we're going to do now, okay, we are concerned. So how are we going to actually resolve our concern? Let's find out these users. So what I'm going to do, like I mentioned, once we run the left join, our left side is going to be populated, but our right side is going to be empty. So what I'm going to do, I'm going to say, okay, so now I want to see all those IBN where IBN is null, right? Because that means it is going to return all those records where we have the user ID present on the left side, but we don't have the corresponding right side present. That's why the right side is going to be completely null. Let's run it. So now you can see we have exactly the same count. You can see, guys, in here we have 171,000, and we have 171,976 records. They are matching, which is good sign. So you can see we have all these users who did not rate any book, and these are all unique users, right? So which is a bit alarming for us, right? Because we are concerned That's not a good sign that if we have more than 100,000 users who are not, liking our books, we need to redefine our business strategy. Anyway, that's a side topic, but that's how we will use left and inner join. Now, to complete the topic, we're gonna now investigate what is happening on the right side. Is there any rating which is sitting and which is sitting there without any user? Like, which are more like the orphan rating, where we don't have the user information, but we do have the book information, and none of the user have read these book, because that's going to be pretty concerning as well. I know it's a bit funny, like analytics always raise concern, because these are more like the concerns for improvement. Put this way, every concern which you're gonna head towards, it's gonna leads towards some positive finding or positive outcome. So let me just mark it left outer join, and last but not the least, let's run it. And now in that, let me first run it without any condition, so we see how many records we're gonna get it. The only thing, the good news, you just need to change the keyword. Everything remains same, and just to actually show you the graphics, now you can see the sign has changed from left to right side, and once you hover over it, you're gonna see that the SQL is pointing out that it is the right join. I would recommend guys to use SQL Express edition on your developer machine, because SQL Express really help you to understand and learn the SQL language in a really powerful way. It's free, there is no limit of using it. There is obviously there's restriction on the features that is those are available within the product, right? So for example, you have a limited space, you cannot go beyond that space. If you want to, you have to buy the license to use it. But from the learning perspective, SQL Express is great. Or once you feel that, oh, SQL Express is giving a problem, switch towards the developer model, because developer is always going to be free with all the feature sets available, as long as you are not using it for any production or business purposes, right? So that will really help you, and you can see with these graphical interfaces how quickly you can start learning. Learning how to build these queries. So that's the thing I want to show. The direction has been changed from left to right, and the diamond is still there. So let me cancel it out, and now I'm going to run it again. Okay, so we have now full, because we are getting the full rating data. So we have now full 1.1 million, 1.149 million records are returning. All right, guys. So let's see. It's not the left join. And now I'm a bit curious. What are the books who are not totally rated by the user, right? I need to know these titles, so I can find out whether why, because we have user liking so many books, right? So why these titles are not rated by any user? Is there any problem with the title? Is there anything that I can find it out for my business to improve that? But in order to do it, the very first thing I need to find out what the titles are. So let's go in here, and I'm going to now, remember, now we are going to, because we are extracting the information from in the right outer join, we are extracting information from the right hand side. So left is going to be empty. So we need to reverse the condition. So instead of, putting TBL book rating, what I'm going to do, I'm just going to say TBL underscore user, and user ID is none. So let me run this. I think we're gonna see which titles are completely unrated by our customer or user. So we have good news. We have less title which are not rated completely. We have 11,299. Now imagine from the stock perspective, we are concerned because maybe we have already paid the cost to the author and we get the permission and we are already paying it. But these are the title which are staying there and which are not contributing into the business at all, right? And I think 11,299 is not a small number, right? So now you can see within these three joins, we have identified three big areas of our business, and we already start seeing the insights that we normally unfold through the data and analytics. So that's where the whole the whole power of scripting comes into the picture, and I believe that will really help. You have heard all these hype about data and analytics, and you're gonna see that once we move towards the dashboarding, you're gonna see right now you are seeing in number. Once we're gonna actually put it in the picture, you're gonna find out how amazingly it actually show the flow of the information. It actually help business to visualize, and then they can make the decision based on that information. So I think that that's enough for this video. We're gonna split it into two parts, and we're gonna have the full outer join and the anti inner join in a separate video. So stay tuned for that. If you like the video, please like the video or subscribe to the channel if you haven't done so, or put any comments if you have any question. More than happy to answer. Otherwise, happy data and insights work, and I'll see you in the next part.